Okay, so here we are asked BD is a tangent to circle. So here's BD. Then we are asked prove that ABD, that's ABD, is what? Is similar to what? To BCD. So let's go. First and foremost, what we want to do here is we say in triangle. Triangle who? Triangle ABD. And triangle what? BCD. Now ABD, very clear. ABD. Your ABD. Alright, so I think we can be very clear that ABD, what we have there is A, which is empty, B, which is B1 plus B2, and then D, which is just empty D. Then we have BCD, B, which is B1, C, which is C1, and then D, which is AMD. All right. Now, we can then obviously first write down our first pair, because after identifying the respective angles for the triangle, all right, that we are working with, we then have to pair up these angles as you see them. So A is supposed to be equal to B1. And if we can find a reason, that would be great. So what would be the reason why A can be equal to B1? And can we state that? It seems like we can say angle A is equal to angle B1. And the reason why we say that is because there's a tangent here. This here, BC, is a chord. And obviously this angle will be equal to the angle that is subtended by this very same chord BC. So this angle here, which is made by this chord and this tangent, which is angle B1, will be equal to the angle in the alternate segment. So we can say A is equal to B1, angle A is equal to angle B1. Reason, angles, reason, tan chord theorem. All right, okay, I think that's fine. Then angle B1 plus 2, okay, should be equal to angle C. But you know what, we can leave that for now. Angle D is equal to angle D. Now it's the same angle D. It is a common angle. So we can say angle D is equal to angle D, that's 2. And we can say common angles, right? Then lastly, we can then say that B1 plus B2, which is ABD. So I'm just going to say angle ABD is equal to, remember that B1 plus B2, which is ABD, angle ABD is equal to C1, is equal to angle C1. We can then say sum of angles in triangle, or we can say interior angles of a triangle, or we can say angle sum in triangle as per the acceptable reason. Therefore, we can conclude that triangle what? Now, in that order that had been stated, we can say triangle ABD is similar to triangle BCD. Just as it was given to us, we can just write it down. And then very importantly, we don't forget this guy, angle, angle, angle. Or we can say AAA, which also stands for angle, angle, angle. It's really up to you how you are going to write that. So guys, what's important here is these first two pairs of angles that are equal as per the order in which the triangle letters are written. This angle A, which is angle A, is equal to angle B1 as it is. This angle B1 plus 2, which is angle ABD, is actually equal to angle C1. We just need a reason. Angle D is equal to angle D. Those are common angles, so that was fine. Then we have our first pair and then our second pair with the right reasons, and then our third pair of angles you can just write sum of angles in triangle. And then you conclude triangle ABD as it was given to you is similar to triangle BCD in that order, and then you write angle, angle, angle. Please guys, this part usually learners forget to write that part and they lose precious marks. Then you see here it says hence find the length of BD if what? If CD is equal to 8 centimeters and AC is 10 centimeters from triangle ABD similar to triangle BCD. Hence find. So when they say hence, it means we need to use something that we've done above. So let's go ahead and do that. There's triangle ABD. We proved that they are similar to triangle BCD, and we know when triangles are similar, it means what? It means that the sides are in proportion. So let's go ahead and say AB, first 2 over first 2 over BC is equal to BD, last 2 over last 2 CD, is equal to first and last AD over BD, first and last. And why do we say that? Similar triangles. Okay. Then AB, all right, over BC. Now what do we have here? The length, we are asked to find the length of who? BD. So this fraction, we will take it. Where is CD? CD is here. What else is there? AC. What is AC? Let's look. AC is a part of A what? AD. You'll see. So it seems like these last fractions, last 2, are going to be the ones that we will take because those are our ratios of interest. AB and BC will fall away. So let's write BD over CD is equal to AD over BD. And then let's substitute the sides that have been given to us. We are asked to find BD. BD is what we want. CD, do we have CD? All right, now what we can see here is that CD is 8 centimeters. It is stated, there it is. So we are substituting in the place of CD, 8. AD, where's AD? AD, we don't have AD. Ooh. All right, AD we don't have. It seems like AD we don't have. Right? AD we don't have. AD we don't have. AD we don't have. But even though we don't have AD, what do we know? We know that CD together with AC gives us BD. You see? Yeah. So it's fine. AD we don't have. But we know that AC plus CD will give us who? AD. And then BD. Do we have BD? Okay, BD we don't have. Let's just verify and check this, guys. Okay. So what did we say? AB over BC is equal to BD over CD, which is equal to AD over BD. Once again, AB over BC is equal to BD over CD is equal to AD over, no problem. Okay, then the BD is repeated. That's fine. Now this BD and this BD will cross multiply, so we're going to have BD times BD is equal to this 8 centimeters into now AC plus CD. Now AC, remember what did we say? AC we know is 10. And then CD is 8. Okay, yeah, no problem. Then obviously this 10 plus 8 is 18 centimeters, which we are going to multiply with 8. Then this is BD squared. But of course, we are going to take the square root on both sides so that we can get BD is equal to, so that will be 8 times 18, which you will guys get for me, and then in the comment section you'll comment and let me know what you got for the length of BD. And there it is, guys. Okay, so what is beautiful is that when we prove similarity of triangles, this is the beauty of it all. Once we prove similarity of triangles, we can state the ratio of the sides, because when triangles are similar, we know that the sides are in proportion. And this reason here, guys, I'm telling you, people don't write this reason down once they state the ratios on the sides being in proportion. So please don't forget that, and then you choose the two that are relevant to the sides that you have been given so that you can work out the unknown. And here we were able to work it out very nicely. BD over CD is equal to AD over BD. Then we are able to see, AD is actually a combination of AC plus CD. AC we know we've got, it's 10. CD we know it's 8, so it's that 10 plus that 8, which is 18 centimeters. Then we just cross multiply, very importantly, we get BD times BD, which is BD squared, and then it's equal to 8 centimeters. We cross multiply the 8 centimeters times the 18 that we have there. Then we take the square root on both sides to get BD. And of course, guys, like I said in the comment section, you let me know what you got. Okay, nice question.